Hi, in this video, I'm going to talk about designing a two-stage LNA using Cree library with the following specifications in the following band. Just like designing any amplifier, we have to follow certain steps to do the design. And just as all the other amplifiers, we first start with biasing the circuit. But the plan is to first design the first stage and have it satisfy all the requirements and then try to match it with a second stage, which is actually a copy of the first stage through an intermediate stage matching. So here we're having a very simple transistor with RF chokes and DC blocks, capacitors. We can use tuning to tune our voltage source to bias the circuit. And every time we can check the current by this button here. And while we are tuning our voltage source, we can see the current passing through the transistor. After doing this stage, it's time to stabilize the first transistor because right now our circuit is biased and we are sure it's operating. For stabilizing the circuit, we can use an RL shunt circuit or RC series circuit. And when we do so, we can see that our stabilization factor is above 1, which is what we required it to be. Then we can add other stages, input matching, output matching stages, and finish the job. For the first stage, here the circuit is ready, and we can see that all the requirements are satisfied except for S22, which we said we are going to match it to the input of the next stage. We can do this matching using a very strong tool called the Smith chart in the tools. By this tool, we can match the output of one stage to the other by the ideal components that are provided for us. In the next stage, it's time to replace the ideal components with real components. For real components, we can change the width and length of them to get the required values for resistance and capacitance, and we have to use vias instead of ground. But we have to notice that vias are having some inductance in them, and if that inductance is affecting our circuit dramatically, we can increase the number of vias by changing the M, which will which will put more vias in parallel with each other, and that reduces the effect of inductance. But for inductors, the story is different. We cannot change the size of inductor and see the equivalent inductance. For that, we can put the inductor in a separate schematic, just like what I have done here, and then we can go write an equation for that and see the equivalent inductance of the inductor. And according to that, we can put it into our circuit. My suggestion is to check the circuit and run the simulation after adding and replacing each one of the components, real components, with the ideal component. The next stage is to replace junctions and connections, to replace the wires actually in the circuit with proper junctions. ADS or cree library offers 3 different junctions for 2 junctions between 2 components, 3 components, and 4 components, and we can change the width according to the components that we have. When we do so, our circuit would turn out to be something like this, and we can generate our layout from it. My suggestion is to generate the layout by replacing each component from the schematic into layout one by one. And one should notice that after everything is replaced, they have to put RF probes for inputs and outputs of the circuit, and they have to put RF pads they have to put pads for the voltage supplies, DC voltage supplies. And for each voltage DC supply, we have to put 2 pads, and 1 pad should be connected to a via, which represents the ground. And when everything is done, here I have put a layout of the design. You can see that DC voltage supplies are on the top and the bottom, and RF inputs and outputs are on the left and right using RF Pro. Okay, thanks for watching.